Okay, in this video we're going to talk about conditional probability in medical testing. And so you can see I've written up a table here. Let me just kind of go over this table, and then I want to talk about some definitions and some things that come from it, and talk about some conditional probabilities with it. And then there's a separate video where you can see an example of kind of how you build a table like this from different probabilities. And so you can look at that as well. Okay, so if you look at this, so this is a table from somebody who's collecting data about a new pregnancy test. Okay, and so they're trying to figure out how good this test is. So the test can be either positive or negative, and the person is either pregnant or not pregnant. And there's some interaction between these two. So you'll notice that most of the people who test positive actually are pregnant, but some are not. And similarly, most of the people who test not pregnant aren't pregnant, but some of them actually are. Okay? And so this gives us two kind of very important conditional probabilities, what's called the false negative and the false positive rate. So the false negative rate is the probability that someone, who is pregnant tests negative. So they are pregnant, but they get a negative test result. And the false positive rate is the probability that someone who isn't pregnant tests positive. So both of these are bad. They're both incorrect results. And so a lot of times when you're talking about a test, you're interested in knowing what these probabilities are because you want to be able to explain the results to people. So if you give someone a positive test result, but there's a very high false positive rate, you might say, yes, this test says that it's positive, but the false positive rate is very high. There's a chance that this could be a fake result, that this might be wrong. Okay? And all medical tests have false negative and false positive rates. It's unavoidable. There's always the possibility of error, that something wasn't correctly done, or that even just the chemicals in it didn't react properly. So these are unavoidable, but in general should be small. Now, in this particular test, they're not necessarily that small. So the false negative rate, probability that someone who's pregnant tests negative, actually is pretty low. So if you think about it, there are 4 people who are pregnant and test negative out of 74 people total that are pregnant, right? So this false negative rate is the number of people who are pregnant and test negative divided by the total number of people who are pregnant, and that is 4 out of 74, which is 0.054, 5.4%. It's not actually super low, but it's not that bad either. Okay, so 5.4% is the false negative rate. The false positive rate, though, is much higher. So if you look at the false positive rate, that's the probability that somebody who isn't pregnant tests positive. That's 5 people who weren't pregnant tested positive out of 19 people total who weren't pregnant. So 5 out of 19, that's a pretty high percentage. 0.263. So 26.3% of people who aren't pregnant test positive. So this is a very high false positive rate. And it's actually not unusual for home pregnancy tests. So home pregnancy tests have high false negative and high false positive rates because they're not as accurate. They're not administered by a physician. They're not actually, people are not being careful about what's being put in them and whether they're contaminated or anything like that. And so they had these high false negative and false positive rates. And that's why you always hear stories about people who tested pregnant at home with the home pregnancy test, but then either they are tested negative and then they went to the doctor and the doctor gave them the opposite result. Okay? So a test like this that has a high false negative and a high false positive and a not great false negative can still be useful, but you need to be aware of kind of what the rates are. Okay? So let's talk about some other probabilities that you can pull out of a table like this that are related to medical testing. So two other probabilities that get talked a lot about are what are called the sensitivity and the specificity. I don't necessarily care if you know these names. I want you to know how to get the probabilities. If you're a nursing student or something like that, you may actually need to know these for other reasons. So I want to put them up. But what the sensitivity is the probability that someone who is pregnant tests positive. So this is kind of the opposite of the false negative rate. So these are the people who are pregnant who test positive divided by the number of people who are pregnant. So 70 out of 74. This is going to be, since this is the opposite of the false negative rate, it's going to be 1 minus it. This is the complement. So 0.946. Similarly, the specificity is the opposite of the false positive rate. So this is the probability that someone who isn't pregnant tests negative, right? So these are the probabilities that you get the correct results. So in this case, 14 of the people who are not pregnant test negative out of 19 total. So 14 out of 19 is going to be your specificity. And that's 0.737. So 73.7%. Okay? And so again, you want sensitivity and specificity to be high. They're the opposite of the false negative and the false positive rate. So if the false positive and false negative are low, sensitivity and specificity will automatically be high. Okay? So one last set of probabilities that we're interested in here, what are called the positive and negative predictive value. So what these are basically the probability that if you get a test result, it's correct. So these are the opposite, I don't want to say the opposite of sensitivity and specificity, but kind of the other way of looking at it. So the positive predictive value or the PPV, and again, I don't care about you knowing these names. I want you to know how to find the probabilities. So this is the probability you are pregnant if you test positive. Okay? So in this case, we want to know the probability that you are pregnant if you test positive. So the top number is still going to be the same. So if we're looking for this probability, we know that you're pregnant and you've tested positive, 70 out of, but instead of dividing by 74, because we knew that we were pregnant, here we know that we tested positive. So we're going to divide by 75. So this is a similar kind of number, but you're dividing by what you already know. So 70 out of 75, 0.933 is going to be your positive predictive value. Similarly, the negative predictive value, our NPV, is the probability you are pregnant, not pregnant, rather, if you test negative. Okay? And so if you're not pregnant and test negative, that's 14 out of the total number who tested negative, which is 18. So 14 out of 18 is 0.778. So 77.8%. Okay? So these are all different probabilities that are related to this. One final one, what's called the prevalence, or incidence. This is the probability that someone has a disease or condition and so in any of these cases, this is going to be the people who have the condition. So there's 74 total who have the condition out of 93 total people. Okay, so it's going to be the number of people who have the condition divided by the total number. So 74 out of 93, or 0.796, 79.6%. Okay? And so what's interesting about medical testing and this conditional probability is that if this incidence changes, it can drastically affect the different rates in your that you get. So if you have the same false positive rate and false negative rate, but a different incidence, so say you're looking at a population where something is much more common. So if you think about something like a disease like hepatitis. So hepatitis is a disease of the liver. It is very common in injection drug users, people who inject drugs into their body, because it can be easily spread through dirty needles. And so if you look at hepatitis in the broad American population, it's very uncommon. If you look at it in injection drug users, it's much more common. And so even if you give these two groups the same test with the same false positive and false negative rates, those other conditional probabilities, the positive predictive value and the negative predictive value, are going to be very, very different, okay, in a different population. So the probability that somebody who tests positive actually has the condition is going to change a lot depending on what that prevalence or incidence is, okay? And so in the other video that I've posted, you'll see an example of how you can take the prevalence and the false positive rate and the false negative rate and build this table and compute some of those other probabilities, okay?